Hello, welcome to session 4. In this session, we are going to do the same project, real-time temperature display, with a state machine. Let's have a look. This is the final work. We have a same sensor simulator and that clear button. But you see, nothing updates in the temp chart because it's now working with the event, not with the time. So when I change sensor value, you can see the chart will update. And again, when I push this clear button, it will clear the chart. So state machine is a event-driven uh, system that helps you to control your flow of program. So let's start from the beginning and design this project with the state machine. Okay, I can start a new project, or maybe it's better to update the same project. These are the elements from the session 2, so no difference. And this is my state machine pattern. I can delete it. Okay. For implementing a state machine in LabVIEW, we can use a switch case structure and event structure together to implement a state machine design pattern. So first of all, I bring a switch case here, and I put a shift register here to have the previous data available, and I can put a enum, constant enum here. So I connect this constant enum to that shift register. Right click on the enum, I can add item or edit items. Here you can see it has no value right now, but I can add, for example, 0 is initialized, 1 is idle, and we could have clear chart and have date chart. Okay, by for now, this switch case works with a boolean value, but when you connect this enum value to its input, it automatically changes to enum. So for now, it has initial default, which is default case, and idle. I want to this idle case to be default, so I can right click here and make uh, this default case. Okay, by right click on this and add case after, you can have clear chart and your update chart. Yeah, so this is my switch case structure of state machine. So every state machine, because it's event driven, is a event manager. Here in idle, I could bring a event structure. It has a timeout. For now, I put this timeout to its default is -1, which is infinite, and I can put it to 1. It's 1 millisecond. So let's start with our state machine. When we are in state initialize, the default is the beginning is initialize. I go to initialize, do some stuff, and I can move my state from the initialize into idle. So I'm telling the state machine that your next state is idle, and that shift register helps me to have that idle here. Okay, when it comes to idle, so in timeout, I have to tell the state machine again go to the idle. So I will stay in idle until something happens. Okay, how can I manage events? Right click here and edit event, sorry, add event case. And in here, I want to add a value chain event for that event button. So, okay, so I have a chain value event for that clear button. So when that event happens, I want to tell my state machine that go to clear chart. So uh, I can handle my clear chart in this state. This is my clear chart state, so I can handle it. You see that empty rectangle here because we haven't determined for the state machine uh, when you came to this state what is the next. So whenever we have done it, so it would be a field rectangle. So when we are in the clear chart state, we tell the state machine go to again idle because the job is done. So let's go back to idle. I want to add another event here, add event case, and for the sensor simulator, I want to add a value change. So when it comes to sensor simulator event, I want to tell the state machine go to update chart. So I can go to update chart state and handle my code here. So when the job finished, I had to tell to the state machine the next is idle. Okay, so it seems that everything done. I can test my state machine right now. Here, can run clear button. You see nothing updates in the chart, but by clicking on the sensor simulator, you can see changes happening in the temperature. So by using seed machine, we converted that time triggered system into a event driven system, which is more efficient because you don't have to check everything by a periodic time. You just have to wait for your events. So it's both efficient from memory aspect and a performance. Oh, okay, let's see what's happening in the program. I can run this highlight execution. So when I first run the program, it comes to initialize and then it all, oh, sorry, I have done something wrong here. When it comes to idle, it goes to initialize, and from initialize, it again returns to idle. So I had to fix it. When it is in idle, I want to tell that go back to idle. So the program starts here, state machine goes to initial state, and from initial it goes to idle, and in idle it waits until some event happens. So Control E, Control T. So when I, for example, change sensor simulator value, what happens here? It goes to the events of the sensor simulator, and from there it goes to update chart. So that's how this state machine works. Okay, thank you for your attention. Next time we do some interesting things with the state machine with more complicated example. Thank you.